Good morning, class. Today we're going to dive into the interesting world of geometry, focusing on a fundamental concept known as the SAS triangle postulate. In today's lesson, we will learn about the SAS similarity theorem and the concept of SAS rule of congruence, using similar illustrative examples. So, let's start. But before that, let's have a short review about congruence and correspondence. Again, when we say correspondence, this simply means pairing and matching. This symbol is read as corresponds to. Next is congruence, which means having the same size and shape, and it is denoted by this symbol. The word congruent in figures means equal in every aspect, majorly in terms of shape and size. Now, are you also familiar with triangle congruence? Triangle congruence means all corresponding angle pairs and all corresponding sides are equal. Today, we're going to focus on proving if two triangles are congruent. The SAS triangle postulate states that if two sides and the included angle of one triangle are congruent to the corresponding sides and included angle of another triangle, both the triangles are congruent. There are four postulates that you need to know: SSS, SAS, ASA, and AAS. And our main focus is SAS. The SAS triangle postulate stands for side, angle, side. What do you mean by side, angle, side? SAS congruence is the term which is also known as side, angle, side congruence, which is used to describe the relation of two figures that are congruent. It's a crucial theorem in geometry which helps us determine when two triangles are congruent, meaning they have the same size and shape. Here is an example. We have two triangles. Let's call this triangle DEF and the other triangle ABC. Now let's say that DE is congruent to AB and DF is congruent to AC. And angle D is congruent to angle A. What postulate can we use to prove that these two triangles are congruent? So we have a side, an angle, and a side. So it's side, angle, side, SAS. So we could therefore say that triangle DEF is congruent to triangle ABC. Here is another example. We have triangle GHI and triangle JKL. Let us find the corresponding sides and included angle on both triangles. Side or segment HI corresponds to LK. Side or segment GI corresponds to JL. And angle GHI corresponds to angle JKL. After finding all the parts of the two triangles, we can now conclude that side HI is congruent to side LK. Side GI is congruent to JL, and angle GHI is congruent to angle JKL. If that's the case, therefore triangle GHI is congruent to triangle JKL. Remember, when applying the SAS triangle postulate, pay close attention to the given information about the sides and angles of the triangles. Now, why is this postulate so important? Well, congruent triangles have identical measurements for their corresponding sides and angles, which means they are essentially the same triangle. This concept is not only crucial for geometry, but also has practical applications like engineering, architecture, and even robotics. Under the SAS criterion, if two sides of one triangle is equal to two sides of another triangle and the included angle between the sides is equal, then the triangle is congruent. This criterion, abbreviated as side, angle, side, is a fundamental theorem in triangle congruence. SAS congruence specifically focuses on the relation between two figures, where all the corresponding sides and angles are equal. Alright class, that wraps up our exploration of the SAS triangle postulate. Remember, geometry is not just about angles and lines. It's about understanding the world around us and how shapes interact.